Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and today we're going to be building a custom config shell. It's a great way to give limited access to your users to be able to configure your Raspberry Pi projects. Also, we're going to be enabling serial console to be able to actually go through without having an IP address to be able to perform that configuration, or at least get your project up and running. So before we get into it, be sure to hit that like button, and if you haven't subscribed, please subscribe. But stay tuned, we're about to get extended. Okay, so here we are. We have a SSH console pulled up. I have it going to a Raspberry Pi 4 in this particular case, but the particular version of Raspberry Pi doesn't actually matter. And what we're going to do is we're going to be creating a custom config shell. And by creating, I mean we're just going to be reviewing something that's already built at this point, just to save time. But there will be some examples. I'll put a link down in the description. I did take these particular examples from somewhere else, but it kind of provides a good framework for you to be able to go through and actually build your own to be able to configure the types of things that you need. So the first example that we're going to get into, is very basic. And pretty much what it is it's just doing text output. It's saying what your options are, and I'll show it to you right now. If I'm on the right computer. We'll do /shell1. And pretty much what it's going to do is it will just output what the options are, and it'll prompt you for a selection. All right, so if we want to see the system information, we can type 1. It'll show us the uptime. Then it disappears. In this case, there's no way to actually get out of it. There's also 2, which will show us disk space. And then 3, we could do what our home utilization is. And again, it's going to disappear after a second. And once we're done, we can quit. So why would you want this kind of limited interaction? Instead of having like a full shell where you have commands that you can type in, kind of like what ships by default with Alpine Linux, you might want to actually have, a way to provide a more secure type of interaction for users, especially if it's something where you have a lot of proprietary, or I should say custom kind of configuration on there that you don't want them accidentally messing up, or there's a very specific way that they need to be able to interact with it. So that's one of them. So a secure way to initially configure devices. It also prevents unauthorized shell access. Can limit users to specific tasks and explicitly list the available user actions. So that way they don't have to guess what the commands are or know how to even use Linux at that point. So this is kind of a basic example. I'll show you what it is. And pretty much it's written in Bash. So the only thing that we did here is we have our options being output explicitly. And then we're just reading for a response. And then based on that response, we're just doing a case statement, which actually does the lifting and the heavy work. And then it sleeps for a delay. So if we input something that was not valid or otherwise did not have an appropriate option, it would actually just cycle back through and reprompt. But that's it. So it's a very simple type of environment for the user to be able to interact in a way that is highly constrained. Now, in order to get that far, I just had to install Bash, right? So I did apk add bash, right? In this case, it's already installed, and I am running an older version of Alpine, but it works the same regardless of which version it is. But pretty much, it's a good way to get off the ground without having a lot of complexity. But there is a better option, and that's to use one of the existing Bash, like text mode, pseudo GUI type of implementations. So one of them is called dialog. And I'll actually show you up here, but dialog is pretty much an application that you can call that does quite a lot of things. Lets you do calendars, lists, edit boxes, basic forms, messages, things like that. And scrolling down here, it gives you something more along the lines of this. And you may have seen some of these before if you've ever used Linux for any period of time. You know, it's common to have, especially during installations, things like that, if you need to do a confirmation or acceptance for terms of service, you would have to select and accept one of these things. There's also things like radio buttons, choosing of files, etc. And this is from linuxcommand.org. So it's lc3_advanced_dialog. I'll put a link in the description. But pretty much, it's a really good way to get that extra kind of polish and make sure that it's not just an overwhelming command line or showing your previous requests. So it's a really clean way to do it. And I have a second example here. Both of these examples are from that website in this particular case. So if we do /shell2.sh, we get the same options that we did before, but now we see it through the dialog. So we can go here, we can see the uptime, we can see our disk space, and now notice it doesn't go away automatically, it has an OK button, which is a lot easier to deal with. Or we could display our home utilization. So, and then we can exit. So it's the same behavior, but it's a little bit more polished. And the way that we actually installed that was we did apk add dialog. And in this case, it does need bash as well, so we'd use the same command as before. In this case, it's already installed. So let's say we want to use shell 2 in this particular case, and we actually want to make a dedicated user that logs in and uses this just as its shell. So let's go ahead and copy this. So we're going to copy shell 2, and we're going to copy it into /bin. Okay? Now we want to add it to LBU, because obviously we don't want it to be deleted past reboots. So we'll do LBU add /bin /shell2, and then we can commit that. And we already have the dependencies installed, so those will get preserved when we do LBU commit as well. So now let's set up our user. So first thing we're going to do is we're going to add a group. So we'll do add group, config user, and then we'll do add user -s /bin /shell2.sh, and that's going to define the shell that they're going to use to log in. You know, normally you would put in something like bash or ash as the shell. And then we're going to do -g to define a group, config user, which is the group that we just made, and we're going to give it a name. So we're going to call it my config user. It's going to ask us for a password, so I'm going to put in a very secure password. We could also set it up without a password and use an SSH console, but if this is going to be something where you're giving it to your user for the first time and they've never interacted with it, it's going to be a lot easier to just tell them to log in with a password than it is to log in with an actual SSH key. And something else is this can actually be used to easily edit the SSH keys to log in more securely otherwise. So it's that limited interaction to be able to do it. You know, it's not a replacement for other best practices, but it is a good way for a custom project to be able to at least have that initial onboarding process. And then it's also, I see somebody chatted, can you configure OpenVPN server in SSH? I think we'll have to do a different video for that. OpenSSH is really, or OpenVPN is very good, and you can do SSH across it very easily. So building OpenVPN servers and being able to log in through SSH is a good way to do that. But yeah, we'll cover that in another video in the future. So thanks for your question, though. So now that we have this, we need to just make sure that our user is unlocked. we did set a password, so it should be unlocked by default, but to do that, we're going to do passwd -u for unlock, and then the name of the user, which is my config user. Says it's already unlocked. That's because we set a password. If we set an SSH key and no password, we would have had to do that as well. But let's go ahead and commit this now. So first thing we want to do is we want to add our home directory. So we want to do lbu add /home / my config user. Right? Because that made that as part of the, it made that home directory as part of the user creation process. And now we want to do lbu commit -d. So now that we've actually done that, we can duplicate our session and we can try and log in with it. And let's make sure that that works. So we're going to do my config user, our password, which is going to be very secure, and we see it immediately logs us in to the shell that we just saw a second ago. Right? So we can see uptime, we can see our disk space, we can see our home space, our home directory utilization, which in this case is 0 because we have nothing in there. And we can exit. And when we exit, the shell entirely goes away. It doesn't exit back to command prompt unless you want them to be able to exit out to a command prompt. So it keeps that layer of security, so they're not entering arbitrary commands, they're entering predefined and pre-approved commands. So now that we've done that, you know, there may be a circumstance where in your use case, you need escalation. So if you do need escalation, it's easy to be able to add that. So just for demonstration purposes, we don't have any need for it today, but I will show you, is we're going to do apk add doas. And what this is going to do is it's going to install the doas command. And so it will do it as root for another user. So we do doas and then the command that we want to run. To configure this, to make sure that it works with our user, we're going to type this command. So we're going to do echo quotes with permit no pass because we don't want it to prompt for a password. :config user. All right, and that's the group that we defined earlier. And in this case, I did capital U for user. So we could define this on a per user basis, or we could define it on a group basis. In this case, we did it by group. So that's why we explicitly defined the group before, and we can make additional users that will follow along and be allowed to run the same commands. So from there, we want to do as root, which is the user that it's going to run it as, and then we would put in cmd followed by our list of commands. So an example would be like reboot. So if we want to be able to reboot the machine without having the user have to be root in order to do that, which is normally the case, we can do as reboot and then be able to do it. So we're going to echo this into /etc /doas.d /config user.conf. And when we do that, we can log in as that user. We can add an option to that shell. So, for example, we can do vi /bin /shell2.sh. And we can add a fourth option here. So the slash at the end means that it ignores it. So we're going to do option 4, and we'll do reboot. And actually, we don't need that new line there. So now when we go down here, we're just going to add another option for reboot in this case statement. And pretty much what we're going to do is just put reboot, followed by 2 semicolons to say that's the end of that case. Otherwise, it will keep going through and just keep processing whatever the next line is if you have more options after that. So now that we have that all defined, let's write that out. We'll commit it. And now when we log in with our user, and actually, I'm just going to duplicate the session just because that's easier. So right now we have it pulled up. Right, we see our menu here. Yeah, and it's not as graceful in the full screen, but if it does reload when it is in full screen mode, it shows up fine. But we see this new option here, which is reboot. So now that we've actually defined all of our things, we've done the do as, it actually may give us an error here because I didn't put do as. So let's see what it does. Oh, it didn't do it. Let's correct that. So that's a typo. Right, so we have reboot here. We do see that showing up correctly, but here, we need do as reboot, which I didn't put in insert mode. That's why it started overwriting. Save that out, commit it so it persists past reboots, and now we can duplicate this again. And I'll go full screen for this. See, it shows up fine. So now if we do reboot, it should reboot this session and we'll see it disconnect. Right, so we see it did successfully reboot the machine. And I can actually switch over here so we can watch it come back up. So that's a great way to be able to add that basic type of interaction with your user without having to worry about, what they're going to do. You don't want them to accidentally delete a bunch of files that it's going to need, or start modifying things that could cause a security compromise. So it's definitely a good way to be able to make sure that that's the case when you are trying to make an embedded device. So this one is now inactive, so we'll go back here, we can restart this session, and let's configure this to be able to do this over serial. Okay, so I'll clear the screen. So all our shell is working as expected. So now we want to create a TTY to serial console. I'm just going to quickly scroll down on my notes. There we go. Okay, so what we're going to do is there's a few ways to go about this, and some reasons that you would want your serial port to act as your console is, let's say you don't actually have a monitor attached to this. And that's what's called a headless installation. You'd want to be able to have some way to do that initial configuration or be able to log into it to set the IP address or otherwise. And that's also a great opportunity for your constrained shell, because you can add in all of that capability to be able to modify your IP address settings, and you won't get kicked out if you change them. So we're going to be adding a Getty, as it's called. And what a Getty is it's pretty much a program that manages the terminal and protects the system from unauthorized access, right? So it's your login prompt. So we're going to add one of those to the serial port itself. And that will let us do all of our login. Now, I want to just note one quick thing about the Raspberry Pi. And I do have a Raspberry Pi here. So this right here is a Raspberry Pi 4. Happens to be in a weird mount, but we have the GPIO right here. The GPIO itself is where the serial breakout that's native to the Raspberry Pi is located. But the issue is that the Raspberry Pi only does 3.3 volts on the actual serial connection. So it's entirely possible that it may not be compatible with all serial adapters. So you may need what's called a level shifter, and to shift from 3.3 volts to 5 volts or 12 volts, which is what the serial standard actually allows for. So just something to keep in mind. It may not be compatible. So I will show you how to do it for the onboard serial, but we're actually going to be using a USB interface, which makes it a lot easier to be able to interact with it, since it's going to be more likely to conform to the standard. So we're just going to be using that for today, but to be honest with you, as long as it's compatible electrically, there should be no difference between these two. So I'll show you both. All right, so first thing that we're going to do is we're going to modify our init tab. So we're going to do vi/etc/init tab. In here, we have all of our TTYs, and TTY stands for teletype. Don't ask me why we still use it, but it's more of a legacy for how consoles used to be transmitted over phone lines and things like that. It's pretty much text over serial data over, it's your text console. I'll put it that way. So in this case, we have everything on our local system using TTY 1 through 6. And we see it actually does have like a baud rate, and it tells us it's using TTY 1 through 6. So if we had 6 separate monitors connected for 6 separate workstations, we could use those. But we want to do serial. So if we wanted to use the onboard serial, what we would need to do is just uncomment this here by deleting the hash at the beginning of the hashtag at the front of it. So it'd just be TTY S0 : respawn, etc. And it's using a baud rate of 115/200. And the rest of it is not really all that important. But once you do this, there's a few other things that you have to go through. So you would uncomment this, save it out, and then you would actually have to go in and make sure that it is enabled on your system. So just for example purposes, we would have to set up a user config. So we do, first we would mount our drive. So mount-o remount rw /media/mmcblk0p1, which is our drive. So we'd mount it to be able to write to it. Then we would do vi/media/mmcblk0p1 user-cfg.txt, and it may not exist by default. When we're in there, we would need to add enable_uart equals 1. And this will allow the onboard GPIO-based serial connection to be active. Otherwise, they're just going to act as regular serial pins. So this is needed, and you do have to reboot after you actually enter this and create it. Once you're done with that, we go back and we do mount-o remount, RO for read-only, media mmcblk0p1. It's not required, but it's good practice to do it, and then we would reboot. In this particular case, I already have it, but we could check and make sure that we actually have it by doing ls/dev/tty*, and we can see right over here, it's showing up /dev/tty_s0. So we would be able to use that to be able to serially communicate if we had an interface that was able to connect to it. So for our purposes, we're actually going to be using this one down here, which is TTY USB 0. And again, you plug it in, you can plug in a number of USB devices, USB serial devices, and they'll just count from 0 onward. So choose the one you want, and then we can use that. And pretty much we would enter the same exact thing that we wanted to otherwise. So we would go back to our init tab, right, which we set up for TTYS0. Right, I'm going to comment that back out. So to do the USB, we would do TTY USB 0 : respawn : /sbin /getty space -L, capital L, and then we do TTY USB 0, and then we would put our baud rate and VT100 at the end. So now that we've added that, we need to make it take effect. So we could either reboot the machine, and before we do that, we want to do lbu commit-d, or we can actually just kill it and restart it without having to restart the entire machine. So we would do kill -hup, all caps, 1. And we don't see any change here, but it does take a change on the back end. And to show you that that's the case, I'm going to open up another SSH console here, or another PuTTY session, I should say. I already know it's COM4, and all I'm going to do is set my COM port and set my baud rate. I'm going to open it, and it's going to look like there's nothing there. But if I hit enter, we do see it actually comes up with a text. Remember that the serial doesn't know when you actually log in. It only knows when you send it text characters and things like that. So you have to hit enter usually in order to get any kind of prompt to show up. So we're going to try and log in, and it's not going to work, and I'm going to show you what it does. Oh, it did work. Shucks. Well, it won't let you log in as root. So let's actually exit out of there. And notice because it's a serial console, it doesn't actually close the window. Because again, it doesn't know when it ends. But if we did try and log in as root, for example, it won't let us do it. And it says login is incorrect. Now, let's say we actually wanted to be able to log in as root. We can go back over to our SSH console that's already logged in, and we can add an entry to our secure TTY file in the etc folder. So we do vi/etc/secure TTY and open it up, and we see a list of all of the possible TTYs in here. But one that we don't see is our TTY USB. If it was TTY S0, that would already be here. So it would already be trusted, and we'd be able to log in as root once we were able to connect to it. But to add a new entry, we would just do TTY USB 0, just like we did before. And we would save that out, and we don't have to do it again. We just literally go in here. We don't have to restart anything. We can do root. Notice how it prompted us for the password this time. And now it lets us log in. And we can do exit to exit. Always be careful about putting root access through the serial port and walking away from it, because even if you unplug the cable, it's going to stay logged in at the state you left it. Make sure that you always log out of your serial consoles before disconnecting. So otherwise anybody could walk up with a serial connection and then they have root access to your system. That's one of the reasons why having the constrained config shell is very useful, because users don't always remember to do that. So it's good to put in fail-safes to make it respond accordingly. And again, if we wanted to revoke that access for root access, we could just delete that from the file. Same thing with S0. for the local serial port. Okay, so now that we have this, we're happy, everything's working, right? We do my config user, type in our password. May have typed it incorrectly. I did type it correctly. Right, we can display our system information. Notice how it shows up in black and white here. But it's still showing up accordingly. So it is working the way that we expect. But we can reboot the system, and there's one thing that we will not see. We will not see it booting up over the serial connection. And that may be desired, but maybe we want to see it boot up from the start to finish. Right, so I'm going to hit reboot. It's going to do the reboot right now. So if we actually go back over to our other view where we see the individual device, we see it's currently off and it's currently rebooting. Right, we see this going across here, but we're not seeing anything on the actual serial port. It's just staying at whatever the last screen was. And if we try and communicate it with it, nothing's going to happen. It's not even going to type. Right, and here we see that it disconnected. But when we do get back to a login prompt, we do see now it pops up, welcome to Alpine Linux, do you want to log in? So how can we make it so we can see all of those login messages as well? So the easiest way to do that is we actually want to just add something to our command line file in our boot folder. Make sure I need to reconnect because we rebooted. So I'm logging in as root again. And what we're going to do is we're going to make it so we can see those boot messages. So we'll do mount -o remount rw /media /mmcblk0p1. Then we're going to edit our command line file. So we'll do vi /media mmcblk0p1 /cmd line.txt. And that's just going to be in the root if you use the image from Alpine Linux. If you install the different bootloader like Grub bootloader or something else like that, I'll put a link into the description that is from the Alpine Linux wiki that will go over the different ways to be able to do this. This particular one is not listed, or at least explicitly. The other ones have you go through more complicated means, but because this is not using any special bootloaders, all we're going to do is add something right to the end right here. And we see it says console equals tty1. We're going to do console equals tty USB 0, comma, and then our baud rate, so 115/200, and then we have to put some additional characters. So N for no parity, 8 for 8 bits per word, and D, which I forget what that is. So no flow control. So pretty much that's all we need to add. We save this out, and now we can do mount -o remount ro /media mmc, just like we did before. All right, and because it's on the drive itself and we just modified it directly, we don't actually have to go in and try and do LBU to do it. We can, but it won't actually do anything. So now let's go ahead and reboot, and we'll look at our serial console and see how it responds. So we see it closed our SSH connection. Our serial connection is still there. We're going to go over to our Raspberry Pi output and wait for it to actually start booting. So we see it booting here. Let's go back over to our serial console and see what it's doing. And it should be doing things. No, It worked during testing. So I'll put in the actual code at the bottom there, but pretty much it still gets you in. So if you create that simple command line modification, it's supposed to do it, but again, sometimes it doesn't use the command line. I'll have to check my installation. So I will put a link down to actually do the more advanced ways to do it, which include going through Grub and modifying the Grub bootloader. I've had some issues with Raspberry Pi trying to do that for this, but there are a number of other ways that handle things like doing virtual machines and other things like that to be able to do it. But again, once it comes up and finally boots regardless, we can log in with myconfig user, put in our password, and securely configure our system to be able to work in the way that we want. So that way, all we have to do is give it to our user, give us a few basic instructions, and not have to worry about them messing up our system. So thanks for watching the stream today. If you like it, be sure to hit that like button and leave a comment down below. And if you haven't subscribed, please subscribe. It helps me out with a lot with the YouTube algorithm. And if you know anybody who would like this kind of content, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. And make sure you hit that notification bell. That way you know the next time we're getting extended. So until then, take care.